recursive digit sum. This is a fairly easy problem where there is one catch. The number which we are calculating, like the number given us is very big, and this particular number cannot be taken in the long int as well. So we have to take that particular number in string. So what basically question asks us, so they give us particular string or number and multiply it. So let's say 148. So we have to multiply it by 3, like add the particular number 3 times. So 148, 148, 148, and after that we have to find recursive sum of it. So it is called super digit. So in this case, this is fairly easy, but as I said earlier, a catch with it. So if we look at the solution for this, so one might think, like, let's say it is, let's say 148, and one would find the sum, that is 5 and 8 makes it 13, and again the sum would be 4. So we are getting a basic hint how to go into the recursive direction for this. So what generally anyone do is that, use particular for loop. Let's say I have copied it. Anyone with the sane mind would go for this particular loop. So one will check for if the number is less than 10. So let's say if you are given a 4 only, so we'll check if 4 is less than 10, and if that is the case, we'll return 4. And after that, let's say the given number is not less than 10. So what we will normally do is we'll use while, and we'll find a particular number. So remainder is like last number, like 8, 4 and 1. So we would be counting them and counting all them in particular sum. So after first iteration, the sum would be 13, and we again passing the sum. So we get 13 as a sum, and we pass 13 sum again to this loop. So it is again checked, and later gives us the result 4. So the drawback with this particular approach is, so we know that in our program or in our computer there is stack call. So all our functions are stored in stack. So in this recursive case, and if the number is very large, and yes, it is very large, so it is like 10 to the power 10,000 times. So it is very large. So number of recursive functions call in the stack would be way higher, and there is a possibility you might get stack overflow in this case. So I in beginning I done with this particular approach, and I failed 4 test cases. So I have revised my approach, and that's why I made this video. So if anyone watching this, or if I'm watching this in a later stage, so I would be it would be helpful for both of us. So let me clear this. In mathematics, there is provision. Let's say if you have any number, let's say number A of base B. So A may be any digits, like any number of digits. That should not be the singular or something like that. Any number of digits, and B is the base, that is like 2, 4, 8, 16, 10. So the sum of the digits of A is always equal to the remainder by B minus 1. So if I put this way, let's say sum of, so as I saying earlier, sum of digits of A is always A mod B minus 1. So let's take any random number, for example, let's say 82. So, and it has base 10, or generally our number system has base 10. So if we need to find the sum of digits of this particular number, so that would be 8 plus 2, that is 10, and again we add 1 and 0, so it would return us 1. So if we go by this formula, so it would be like 82 mod 9. So 9 9 is 81, so it would return us 1, and it is 1 in the both cases. So again, take the any random number. Let's say let's take any random number. Let's say 5, 4, and 7. So 5 and 1 9, and 9 and 7 16. So 16, 1 and 6 would result into 7. So if we mod 547 by 9, 547, so this is fairly easy. So 9 6 is 45, and the remainder is 7. So we know that in both cases our results are matching. So let's take another example of like a big number, so we can test this particular solution is working for all cases or not. So I'm taking a random number 1 2 3 4 5. So the sum would be 3 and 3 6, and 10 and 15. So 1 and 5 would result into 6. So if we have to divide this particular mod this particular number by 9, so result should come as 6. So let's check. 9 ones are 9, and remainder is 3. 9 threes are 27. Remainder would be 6. Then 9 sevens are 63. Remainder is 1. 9 ones are 9, and the remainder is 6. So we know that like this particular solution or hack works. I don't know the particular theorem name, but we can generalize this particular theorem as sum of all digits of any particular number is equal to a mod base minus 1. So this is the solution. So after that, coding is fairly easy because what we are doing is we are more like using mod 9 because our base system is in 10, mod 9 to every case and shortening our number. So because we have been given like 10 to the power 10,000, so we would be having huge number. So what we are essentially doing is we first calculating the numbers, like adding the numbers, and we are modding it by 9, and after that I'll show you the code so you can analyze it. This is coding part. So we'll first include library files, include stdc++ storage. After that I will be adding single space std name. So we know that we have one string, let's say it is str, and another is multiplier number key. So after that we will take those numbers in str. So here is another mathematical property you should be knowing is if we multiply any number by 9, so let's say any number you take, you name it. So if we multiply it by 9, the resultant sum is always 9. So let's check. 12 9 that would be 108. So the resultant sum is 9. any number like 4 into 9, so that would be 36. The resultant sum would be 9. So as our in this case, let's say if k, given k, we decide to mod it by 9. As I said earlier, we are usually modding everything by 9 so that we can get, like, we can minimize the numbers and get the result. So in this case I have used mod on k. So if k returns me 0 value, so let's say if it is a 9 or 18 or multiples of 9, so that means that particular number would be multiplied by 9, and hence the resultant sum would be always nonce. So I can directly see out sum that is 9. Okay. And in else part, if that is not the case, then I would be, so in else part, let me add int sum. So our sum would be the resultant sum. So let's say sum, and then I will call a recursive function, that is, let's say, sum of all numbers in short. So I will pass the string str, and let's write the sum of all functions. So this particular function would return us the resultant sum. So int sum of all, it takes string str as parameter, and in this case, so we would be adding for loops. So int I is equal to 0, str dot length, or we can assign this particular value to. So I'll go with the str dot length. If there is any issue, so sometimes there might be error saying you are comparing between different kinds of number. So let's say this particular string length is long int, and I am having I as int. So this comparison is sometimes invalid. So what you can basically do is you can copy this part, take a new variable, let's say long, any variable, long limit, and long length, and let's assign it to the string length part, and I can assign this I value with long, and I is less than length. So what I'll be doing is I need another variable long, or let's say sum, and sum for the string part. So I'll take sum string. I'll assign it to the 0 first. So what I would be doing is I would be adding sum, or let's say total. So we can short this total. So total would be total. I'm assuming everyone knows the basic array addition or string addition. Total plus string of I minus character 0, and complete this. So let's add another bracket, and I'm dividing this whole thing. I'm using mod 9 to this whole thing. So if whenever we do any like our main end game is end goal is we want to find the sum of the digits, and as I said earlier, if we divide it by, mod it by 9, the resultant won't be changed, but the number will certainly reduce. Let's say any example by 30. 30 is a 2-digit number. If we mod it if we find the sum, it is 3 plus 0 is 3, but if we mod it by 9, so this would give us 27, and the remainder is 3. So it will help us shorten the digits. So the sum would be shortened, like in this case total, and after that, so after that we would be returning the total value, total, and in this case also we are using mod 9. So we'll get the sum. So there are two cases. So let's say the sum is 0. Sum is equal to 0. That means that particular value is being like the sum of digits is 9. And I have explained you how this works. Cout 9 else cout. So we can do one more thing as well. So what we can do is I have like forgotten to add the k value. So the sum would be sum into k, and let's mod it by 9, okay. And the sum is 0. Like sum is equal to 0, the sum of digits would be 9, and if it's not that case, the sum would be different. So it's fairly done. Let's check on the site. Let's copy the code. Compilation check total long okay, I forgot the semicolon here. Let's do this as $4,000 years data. Okay, sample test is passed. Let me check if I passed all the test cases. So there were 4 test cases which had like long number and which I failed earlier. So that's why I searched online for this particular method and then made this video in order to help me, and if it helps anyone else, that is good. Okay, it passes all the test cases, and the code is in the description.